Hi, my name is Brooke, and today in this video I'm going to show you of how I determined an unknown compound through 4 different sets of data. So the first set of data that I'm going to look at is an IR spectrum. Here's the IR spectrum for the unknown right over here. And the IR spectrum is going to tell us basically what types of functional groups we have in our compound. So the first peaks that I noticed are 3420 and 3319. These two peaks are going to tell us that we have a NH stretch, specifically for a primary amine. The next peak that I'm going to point out is at 1622 right here, and that is a NH bend, which is also going to say that we have a primary amine. And at around 1479, right about here, we have a CC stretch, specifically for an aromatic, benzene probably. At 1292, right about here, there's a CN stretch, which is an aromatic amine. I specifically looked this up to see if this peak was going to be present, just because with knowing that we have a primary amine, I wanted to know if it was going to be on the aromatic, so that is why I looked that up. So from here, we are going to look at the mass spec. And the mass spec, first thing is to look at our M plus ion peak, which is at 161. That's going to tell us our molecular weight, and the other thing to note is that we have a M plus 2 peak at 163, and it's about a 3-to-2 ratio. So this type of ratio tells me that there's going to be 2 chlorines. And so to support that, we have to check to see if there is an M-35 peak, because chlorine weighs 35, and so M-35 peak would be at 126, and we do have one. And if we have 2 chlorines, there would be an M-70 or an M-71 peak, which we do have, which is at 90. So another reason to show that we have a nitrogen is because of the nitrogen rule, which says that if we have an odd number for our molecular weight, there will be an odd number of nitrogens. And so at the moment, we know that there's an aromatic amine, so 1 nitrogen. So from here, I'm going to use the rule of 13 to figure out our molecular formula. So 161 is our molecular formula. Subtract 84, which is what we already know we definitely have, which are 2 chlorines, so that's minus 70 as well as minus 14, which is the nitrogen, and so we have 77. I divide 77 by 13, I get 5 with a remainder of 12. So as of right now, we have 5 carbons and 17 hydrogens, 2 chlorines, and 1 nitrogen. But we know that there's an aromatic ring, and so there has to be 6 carbons for that. So our molecular formula is going to be C6H5Cl2N. And from here, what we're going to do is we are going to find our degrees of unsaturation. And basically the degree of unsaturation is the amount of carbons, which is 6, times 2, plus 2, minus the number of hydrogens, which is 5, minus the number of halogens, which is 2, plus the number of nitrogens, which is 1. And so for our degree, and then we divide that by 2, so our du would be 4. So that means we have either 4 double bonds and or rings. So that's all I'm going to do for this video, but come back for part 2, which will describe the unknowns, hydrogen and carbon NMR. So thanks for watching.